Okay, hi everyone. I'm Taiki from Tokyo, Japan. And I'm working at Cookpad. And mostly I'm one of Envoy users. And sometimes I send patches or documentation fixes. So you might have seen me on GitHub. And I'm glad to share our case study of Envoy, in which we built simple service mesh with Envoy. So please enjoy our story. Okay, let's start. This is an agenda for this session. I think the most interesting part is the architecture and operations part. So let me quickly explain background and problems, then go to the architecture and operations part. So background, let me explain about our business tree. We are doing in cooking domain, and the most famous product is recipe sharing service, Cookpad.com. We originally started in Japan and started the global platform a few years ago. So we have separated platform in JP and global right now. But let me skip the detail in this session for simplicity. So our scale and structure, we have around 200 product developers and around 100 production services. And my team is platform development team, and it has 3 members, including me. And I'm the only person who develops our service mesh there. And regarding our structure, we have some of product team and one central operation team. And the central operation team still has all of our operations, but we are changing this now. So that why we are building our platform to achieve self-service operations. And our technology stack is almost Ruby and Ruby on Rails. Most of our applications are written with Ruby on Rails for both front-end app and back-end apps. But recently, we have some variety in application language, like Python in machine learning, and Go and Rust in performance required domain. And the right diagram is our typical architecture before. Most of our applications are running on Amazon ECS. So we have some internet-facing load balancers, which was associated to front-end apps. And front-end apps communicated to back-end apps via internal load balancers. And all of internal communication were plain adjacent over H1. So it's very simple. Okay, see our programs. And those are typical programs around microservices, so you know them. System reliability program and observability program. So we started a library approach at first, made historics like library in Ruby, and made distributed tracing library. But yes, as you know, the library approach has a limitation, and it won't work for us. So we plan to develop a proxy, like forking as a proxy, because we were heavily using as a proxy at that time, and plan to manage the proxies with console template or something like that. Then we met Envoy. It looks like what we wanted to build. So we start investigation and start making plan to build our service mesh with Envoy. So this is a timeline. We start making plan and designing architecture in early 2017, and I was back to service mesh in late 2020, then start building MVP and using the MVP in production from that time. And finished making our V1 service mesh in early 2018. And we choose in-house control plane approach. It's because the timing and we are using Amazon's ECS. So I looked up some products at that time, but it seems no product fit our environment and requirements. And I don't have specific information at that time, but I thought there will be some managed services in the future. So yeah, I choose a small start with in-house one. And there are some considerations on building our service mesh. We wanted to manage service mesh configuration centrally and wanted to do Git ops with code review. And next, because we are operating Prometheus servers, all metrics from Envoy should go into Prometheus servers. And we have to keep the operation cost to lower level as possible. So we prefer less components and use of managed services as its backend. Before introducing the architecture, let me explain some key components. The first one is the Kumonos. It is a tool to generate V1 XDS responses from our abstract service mesh configuration. This is implemented as a Ruby gem. And next, we developed the SDS application. It may confusing, but yes. And it's based on Leaf's discovery application, but we added some features on it. This is implemented as a Rust web app. And the Rust, the Itacho tool, this is basically a CLI tool to generate with XDS responses. But it also has a feature to translate with REST HTTP POST request to HTTP GET request. The translation protocol is our original for now. So I'm going to work for that protocol in the GitHub issue. If you have any comments about this, let's discuss. OK, so let's start the architecture. At first, let's start with above in this diagram. There is a central GitHub repo for abstract service mesh configuration. And a product developer can add or change or remove the configuration and push them to GitHub repo. Of course, we can do code reviews before pushing here. And when we push the configuration, a CI task runs and it generates V1 CDS and RDS responses, then uploads them to our S3 bucket. Then sidecar envoys are running in each our ECS task, which is like Kubernetes pods. And the envoys are configured to see our S3 bucket with the red arrows. So envoys can fetch their cluster's root configuration from the S3. And in the CDS response, we place a DNS name of our internal ELB as a cluster member. So Envoy just routes traffic to the internal load balancer. Here, the load balancer does load balancing and endpoint discovery and health checking and so on. We simply change our application configuration to refer from internal ELB to sidecar Envoy. We don't use IP tables here. So the traffic from application container flows to sidecar Envoy, then route to internal ELB, then upstream Nginx. In this way, our plain JSON over H1 service communications were working in our V1 service mesh. This is V1. And so let's see the configuration file. It abstracts Envoy's configuration. We write root configuration and cluster configuration. And it's a JSONet file. And single JSONet file represents single service configuration. A service can have an upstream clusters and upstream dependencies. It's almost same as Envoy configuration, but we do some additional work to inject a retry configuration to get requests and inject some host rewrite related configuration to fit our infrastructure. So this is our service mesh configuration, and they will be converted to XDS responses with our tool. And next, this is V1.1. We started using V1 Service Discovery Service API to build infrastructure for gRPC applications. At first, let's see the SDS app above. It's our customized V1 SDS API server, and its backend is DynamoDB. Then see the blue arrows at the right of this diagram. We run sidecar registrator, which do health checking of the application and register endpoint information to the SDS server. Then Sandoka Envoy fetches the endpoints from V1 SDS API from the SDS app, and the traffic are routing directly to upstreams with Envoy's load balancing feature. There are no server-side load balancers here. But as you know, we now have AWS Cloud Map, so we don't have to do this manual registration now. So yeah, I really wanted Cloud Map before. Okay, then let's see the latest version, which is using V2 XDS. Please look at the top of this diagram. To translate V2 XDS HTTP post request to HTTP GET request for our S3 bucket, we run translation web server between Envoy and S3. It's a Itacho server. The translation server is running as our normal ECS service, so it's hard to use with gRPC XDS. So we are using with REST XDS here. And we can simply use AWS network load balancer because of NLV's cross VPC issues. And for V2 EDS, we implemented V2 EDS API to our custom SDS server. The registration and deregistration are same before. Okay, so this is our service mesh architecture. Then let's see metrics side. This is how we are sending metrics to Prometheus servers. We are using doc.statsd to send metrics in doc.statsd format, which is an extension of statsd format. And then Prometheus statsd exporter are running on each host. So one statsd exporter process per one ECS host instance. Then the statsd exporter receives Envoy's metrics from sidecar Envoys. And our Prometheus servers are configured to discover those statsd exporters and pull metrics from statsd exporter. Regarding the metrics tag, we add specific tags to all of our metrics to identify each metric. Okay, let me show operation side. And to make dashboard, we are using Grafana. We have two different dashboards for product developers, per service and per service to service dashboard. The dashboards are generated using Grafana's template feature. And we have one dedicated dashboard to monitor our Envoy instances. And we have a visitor dashboard to quick look our network topology and service status. And we are using a Prometheus and Prometheus front. And this is a per service dashboard. And we can check upstream RPS and responses retries here. And this is also a per service dashboard. And at this time, the upstream was broken. So we can see Envoy's retry overflow counter was surged for the specific upstream. And this is the Envoy global dashboard. And we can check XDS update status mainly here. And this is our visitor dashboard. And in this dashboard, a single white dot, which is very small in this picture, but the white dot represents a request, and it moves from a node to another node. And if that request ends with errors, that dot becomes a red dot. Seeing this dashboard is a little bit fun, but so I'm sorry for not preparing a movie for this. It's yeah, dots are moving and it's very fun. And this is a per service view, n downstreams and n upstreams. And dots are, yeah, of course, moving. And we are not heavily using these visitor dashboard, but sometimes the dashboards gives us a quick insight of our entire service topology. And we have an in-house platform console, which shows everything about a service in a single view. So developers can view service status by just looking at this page. So we add some information and links to this page. And let's mention about how we use Envoy on EC2 instances. A few services still running on EC2, so we run Envoy processes on these instances. We built Envoy as in-house dev package and distributed it with configuration management tool. And we manage Envoy process as a systemd service, and we are using Envoy's hot.restart.py script. And this is one of operational problems we face. This is waiting issues for initial XDS setup. In the background jobs, we can't wait the service in with health checking. So sometimes the application container runs before initial XDS setup. To handle this issue, we developed a wrapper CLI tool, which waits the initial XDS setup with health checking Envoy. And after waiting succeed, exec application process. And there are some hard points, but we finally handled them, so it's just for information. Okay, so let me show some key results from our service mesh quickly. The first one is observability, and the second one is failure recovery. We have significant benefits in these areas. And because we are now fully managing our libraries, our platform team have more control over platform component deployments. So it increases our team velocity. And okay, next challenges. We started building a fault injection platform to test or experiment our applications and service mesh configurations. And we are planning to migrate to managed services because some managed service mesh services release now. So it's time to consider the migration. Then, yes, thank you for listening. And I'm also looking forward to hearing your cases and stories. So I'm glad if I can talk with you at reception or during KubeCon. Thank you again, and I'm done. Go ahead. Yeah, please slowly and clearly, please. Yes.
In one of your diagrams, you show Envoy grabbing config from either S3 or your other service. I don't remember the name. But is it polling? How does it know when to pull configuration?
Oh, yeah, it's polling. Yes, we run XDS, and with the REST, XDS is polling. So it's polling.
Okay.
Yeah. Go ahead.
Is there a reason why you have the separate EDS service which is separate from the LDS thing?
Yeah, yes. It's not necessary to separate, but yeah, it's just a historical reason. So yeah, we first developed SDS as web application, Rust web application, and so yes, generation 2 implement as Golang CLS 2. So yeah. Nothing. Okay. Thank you.